Dear students, today let us discuss the questions of Grand Test 1 Mathematics. I will discuss all the 60 questions. So, whatever the doubts you have, you can see. Let us look at the first question. The order of the differential equation of all circles of given radius A is given radius A, that means the radius is fixed. Radius is A, that is a fixed constant. Okay. Let us look at the general equation of the circle. General equation of the circle is x minus h whole square plus y minus k whole square is equal to r square, in this case a square, because radius is a. Here h and k are the arbitrary constants and a is the fixed constant. The order of a differential equation is equal to the number of arbitrary constants that is present in that equation. So now there are two arbitrary constants in this, hence the order of this differential equation is 2, which is the fourth option. Let's go to the next question now. Question number, third question. Question number 2. The solution of the differential equation y square dy by dx plus y square plus 1 equal to 0 is. Take that y square plus 1 to RHS, so that you have y square into dy by dx is equal to minus of y square plus 1 or 1 plus y square. Now, I will separate the variables. I will group the terms containing y along with the dy and the terms containing x along with dx. Bring this y square plus 1 to LHS. So, y square by 1 plus y square into dy equal to, take this dx to RHS minus dx. So, now we have separated the variables. Let us integrate this. Integral of, while integrating I will add 1 here, 1 plus y square minus 1 divided by 1 plus y square into dy is equal to minus integral of dx. Okay. So, I have added 1 and subtracted 1. Now, we will split this into two terms. 1 plus y square by 1 plus y square, that will give you 1 minus 1 by 1 plus y square into dy is equal to minus integral of dx. Let us integrate it now. Integral of 1 with respect to y is, so y minus the integral of 1 by 1 plus y square, which is tan inverse y, is equal to on RHS minus integral of dx, that is integral of 1, which is x plus c. Bring this x to the side. So x plus y, take this term to RHS is equal to x plus y is equal to tan inverse y plus c. X plus y is equal to tan inverse y plus c. Second option is the correct answer. Okay, let's move to the third question now. The value of tan 1 degree into tan 2 degree into tan 3 degree etc. till tan 89 degree. Now in this, there are this tan is appearing 89 times, tan 1 degree, tan 2 degree, tan 89 degree, etc. So I will group them in this way. I will write tan 1 degree. I will take the first term from the beginning and first term from the end. Tan 1 degree into tan 89 degree I will do. After that, I will take the second term from the beginning and second term from the end. Tan 2 degree into tan 88 and so on. Tan 3 degree into tan 87 degree, tan 4 degree into tan 86 degree and so on till tan 44 degree into tan 46 degree into, there is one term will be remaining, which is tan 45. So total there are 89 terms here, 89 factors here. I am grouping two factors together. So 49 groups I get plus one single term will remain, that is tan 45. Okay. Now tan 89 degree, I can write this as tan 90 degree minus 1. Tan theta can be written as tan 90 minus tan 89 degree can be written as tan 90 minus 1. Tan 90 minus theta is nothing but cot theta. So this will become cot 1. Tan 1 degree into cot 1 degree into, similarly tan 88 I can write that as cot 2 degree, because I am writing 88 degree as 90 minus 2 and so on. This tan 44 degree I will keep as this, and here tan 46 degree is there. No, I am writing tan 46 degree as tan 90 minus 44 degree, which will give us cot 44 degree. Okay, into that tan 45 is remaining, which is 1. So now tan 1 degree into cot 1 degree is 1, tan 2 degree into cot 2 degree into 1 is equal to 1. So in that way, all these factors give us 1, their product is equal to 1. So you must remember one formula here, that is, if a plus b is equal to 90 degree, If a plus b is equal to 90 degree, then tan a into tan b is equal to 1. If you know this formula, directly divide that this is 1, all of these factors, all of these groups is equal to 1. So the final answer is the product of all those, which is also equal to 1. Let's go to the next question. Fourth question. The matrix, this matrix is, what kind of a matrix is? A very simple question. You observe that the diagonal elements are zeros, and when I take the transpose, I am getting a dash is equal to minus b. Hence, this is a skew symmetric matrix. Skew symmetric matrix, option C. Okay, look at question 5. The sum of the products of elements of any row with the cofactors of the corresponding elements of the same row is equal. So you have one matrix here. Let me consider a 3 cross 3 matrix, and I will consider the corresponding cofactors. I will say a11, a12, a13 in that way, and I will consider the corresponding cofactor matrix. Let capital A11 indicate the cofactor of A11, then A12, A13 in this way. Okay, so this is A21, A22, A23 and so on. Okay, if I multiply the elements of any row with the corresponding cofactors of the same row and add, that is, and if I take A11, A11 plus A11, A12, A12 plus A13, A13, that is, sum of the elements of any row with the corresponding cofactors of sum of the products of any elements of any row with the corresponding cofactors of the same row. This sum will always be equal to determinant of A. But if I multiply these elements with the corresponding cofactors of any other row and I add them, that sum will be equal to 0. Which means A11 into A21 plus A12, A21 plus A13, A23, this sum is equal to 0. See here, the question is sum of the products of the elements of any row with the cofactors of the corresponding elements of same row. If it is same row, then the answer is determinant of A. If it is corresponding elements of any other row, then the answer is 0. Okay. Then let's move to the next question. Question number 6. The intercept cut off by a line from y-axis is twice that of from x-axis, and the line passes through the point 1, 2, the equation of the line is intercept cut off by a line from y-axis. So I will take the general equation x by a, general equation in intercept form, x by a plus y by b is equal to 1, equation of line in intercept form. Here a is the x-intercept and b is the y-intercept. Here what they have done? They have given that y-intercept is twice that of x-axis, or twice that of x-intercept. Intercept made by y-axis is twice that of the intercept made by x-axis. So which means b is equal to 2a. Let me substitute. X by a plus y by 2a is equal to x by a plus y by 2a equal to 1. Now I will multiply this equation by 2a. When I multiply by 2a, here a gets cancelled to it. 2x plus y is equal to 2a. 2x plus y is equal to 2a. It passes through which point? It passes through 1, 2. It passes through 1, 2. Substitute. So if it passes through 1, 2, we get 2 plus 2 is equal to 2a. So 2a equal to 4, which means a is equal to 2. That I will substitute here, which will give you 2x plus y is equal to 2 into 2, that is 4. 2x plus y is equal to 4, which is the option A. Then, 7th question. Which of the following is false? Okay. 4 statements they have given, and you have to identify among them which is false. Okay. A constant function can be 1, 1. Yes, it is possible. See, in general, a constant function is not 1, 1, but if the domain is a singleton set, see, in general, let us say this is what we have. So a constant function, this is a constant function. F of x1 is equal to b, f of x2 is equal to b, f of x3 is b, f of x4 is also equal to b. This is not a 1, 1 function. It's a constant function. In general, a constant function is not 1, 1. But if the domain is a singleton set. Let us say this domain has only one element. F of x1 is equal to b. Then this is a constant function, right? This is 1 also, this is constant also. Okay. So what here the statement says that a constant function can be 1. Yes, it is possible that a constant function can be 1 if the domain is a singleton set. So that is a true statement. Second one, an identity function is a bijection. Definitely true. Every identity function is a bijective function. Then third, if f from a to b has an inverse function, f inverse from b to a, then f is surjective but not injective. So here they are saying that f has inverse. F from a to b has an inverse, and that f inverse is defined from b to a. Then they are saying that f is surjective but not injective. Surjective but not injective means it is an onto function but not 1. Is it possible? No. As we all know that a function is invertible if and only if it is a bijective function. So it has to be injective as well as surjective. So this option C is not a correct statement. So that is the right answer. Okay. Now look at this. If f and g are onto functions from R to R, so is the function f circle g. F and g are onto, then the f circle g is also an onto function. So that is also a correct statement. So false statement is option C, and hence that's the right answer. Okay. Look at question number 8 now. The solution set of the inequality x square plus 6x minus 7 divided by mod x plus 4 is less than 0. Okay. So mod x plus 4, this should be negative. This expression should be negative. That is what they are saying. Now mod x plus 4 is always positive, which means this expression is negative. This inequality is negative whenever the numerator is negative. And another thing that you have to note is that denominator should not be equal to 0. Denominator should not be equal to 0 means x should not be equal to minus 4. Okay. And other than that, denominator is always positive. So we have to ensure that x not equal to minus 4. Then numerator should be negative because this denominator is always positive, hence this expression will be negative whenever the numerator is negative. Numerator is x square plus 6x minus 7. This should be negative. Let us factorize this. On factorization, this will give you x plus 7 into x minus 1. This is less than 0, which implies that x belongs to minus 7 to 1. But this you have to exclude, remember this. So the answer is minus 7 to minus 4 union minus 4 to 1. Minus 7 to minus 4 union minus 4 to 1. First option is the right answer. Okay, let us look at question 9. F from 1 to infinity to 2 to infinity is defined by f of x is equal to x plus 1 by x. Then what is f inverse of x? F of x is equal to x plus 1 by x. I take that f inverse of x is equal to y. That will imply that x is equal to f of y. X is equal to f of y, that is y plus 1 by y. F of x is x plus 1 by x. So f of y will be equal to y plus 1 by y. Multiply by y, get xy is equal to y square plus 1, which will give you y square minus xy plus 1 is equal to 0. This is a quadratic equation in y. Let us find out what is y. Y is equal to minus b, that is x plus or minus root of b square minus 4ac divided by 2b. Y is the f inverse of x. F inverse of x is equal to x plus or minus root of x square minus 4 divided by 2. Okay. So there are two answers here. One is x plus root x square minus 4 by 2, and the other one is x minus root x square minus 4 by 2. And if you look at the options, both options are present. Both the answers are present. It is here, and that x minus root x square minus 4 by 2 is also there. So among them, which is the right answer? Option A is the right answer. Why? Why? Is it because we want to be positive always? No, that's not the reason. The reason is that, see here, f is defined from 1 to infinity to 2 to infinity. Therefore, f inverse will be defined from 2 to infinity to 1 to infinity. Now, suppose if I take f inverse of x as x minus root of x square minus 4 by 2. Then take one value from here. Say I take 3. 3 is a member of the domain. 3 if I substitute, I want to know what is f inverse of 3. Then what do you get? 3 minus root of 9 minus 4 root 5 by 2. Root 5 is approximately around 2.1, 2.2. Okay, let me take 2.2 by 2. This will give you 3 minus 2.2, that is 0.8 by 2, so 0.4. It's approximately equal to 0.4. But that 0.4 is not there in f inverse at all. Okay? So therefore, f inverse of x cannot be equal to this. If it is plus, then what happens? Then you get the 3 plus 2.2, which is around 5.2. This will give you 2.6. Is it there in the codomain? Yes. Did you understand? So it should be x plus the root x square minus 4 by 2. First option. Let's look at question number 10. Let's start with a binary operation defined on Q. Which of the following binary operations is associative? Which of these is associative? Associative means A star B star C is equal to A star B star C. So here look at the first option, A star B is equal to A plus B. Addition is associative, which we know that from last 4 or 5 years ago we know. Okay, so an obvious answer, option A. Then 11th question, if cos inverse x is greater than sin inverse x, then what happens? Cos inverse x is greater than sin inverse x. For this, I draw the graph of these two functions so that it will be easy for us to identify. Okay, sin inverse x, cos inverse x greater than sin inverse x. First, I would like to draw the graph of sin inverse x. It is defined from minus 1 to 1, right? So this is the graph of sin inverse x. Then the graph of cos inverse x, and this value is pi by 2, this is minus pi. Okay? Then because the range of sin inverse x is minus pi by 2. Then for cos inverse x, the domain is minus 1 to 1. Range is from 0 to pi. Its maximum value is pi, which is attained at minus 1. So it is like this. That graph of cos inverse x is like this. Okay, this is pi by 2. This value is pi. As we know, cos inverse of minus 1 is equal to pi. So at this point they intersect. This point is nothing but 1 by root 2. At 1 by root 2, sin inverse x is equal to cos inverse x. We want to know where cos inverse x is greater than sin inverse x. Look at the graph. From minus 1 to 1 by root 2, graph of cos inverse x is greater than the graph of sin inverse x. At 1 by root 2 they are equal. After 1 by root 2, sin inverse x overtakes the graph of cos inverse x. So the answer here, we want cos inverse greater than sin inverse x. Answer should be minus 1 to 1 by root 2. Open it up. This is the answer, which means here x is greater than or equal to minus 1 less than 1 by 2. This is the answer. Okay, through this graph it is very clear. Okay, now I know some of you may not be knowing this graph, so you may be having a doubt, sir, if I don't know the graph, can I not answer this question? Yes, you can definitely answer this question. How? Let me explain. You put some value for x. So as always, let us start with 0. Put x equal to 0, just check whether it holds good or not. If I put x equal to 0, on LHS cos inverse 0 we have. Cos inverse 0 we know, which is equal to how much? Pi by 2, right? And on RHS sin inverse 0. Sin inverse 0 is 0. Pi by 2 is greater than 0, obviously true. So at x equal to 0, the result holds good. So 0 should be there in our answer. Look at first option. Does it contain 0? No. So this option is eliminated. Second option, does it contain 0? Yes, maybe the answer. Third option, does it contain 0? Yes, maybe the answer. And fourth option, it does not contain 0, x greater than 0, so that doesn't include 0, hence first and fourth options are eliminated. Answer is either the second option or the third option. Now we put some more any other value. Okay, so what else can I substitute? Minus 1, now you choose some value such that it is present in both the options. It is present in only one option. Don't put x equal to 1 by 2, because if I put x equal to 1 by 2, I don't achieve anything, because 1 by 2 is present in this also, present in this also. You choose a value which is present in one of the intervals, one of these options, and absent in the other. So I take minus 1. Minus 1 is present here and absent there. And if at minus 1, if this result holds good, then this will be the answer. If the result does not hold good, then that will be the answer. Okay. So in CET, unlike mains, in CET you will always have the shortage of time. How quickly you will get the answer, that is important. So I will go for substitution. Minus 1. Cos inverse of minus 1. Cos inverse of minus 1 is pi. And sin inverse of minus 1. Sin inverse of minus 1 is minus pi. Pi is clearly greater than minus pi by 2. At minus 1, the result holds good. So option C is the answer. Okay. Then 12th question. The conjugate of I into 4 plus 6i divided by I minus 1. That is conjugate of that. Take that I inside 4i plus 6i square. I square is minus 1, so it will be minus 6 divided by I minus 1. Or I can write this as 6 minus 4i divided by 1 minus I. 6 minus 4i divided by 1 minus I. Now we want the conjugate of it. So first we will bring it to the standard form. For that I will multiply and divide by the conjugate of the denominator, 1 plus I. So on simplification, this will give you 6 plus 6i minus 4i minus 4i square. I will come plus 4 divided by 1 square minus I square. That will give you 2. This is equal to 10 plus 2i by 2. That's equal to 5 plus I. 5 plus I is the given complex number. We want the conjugate of it, which is 5 minus I. Third option. Then 13th question. If alpha and beta are the roots of x square minus ax plus b square is equal to 0. Alpha and beta are the roots of this. Then what is 1 by alpha plus 1 by beta? So from this we can write alpha plus beta. Sum of the roots is equal to a. Product of the roots is equal to this minus b by a. So here you get a and c by a. So b square by 1, which is b square. We are asked to find out 1 by alpha plus 1 by beta. That's equal. Take LCM alpha beta. Numerator beta plus alpha. That is nothing but alpha plus beta. So this is a. Denominator is b square. So the answer is a by b square. Option C. Then 14th question. If the second and the fifth terms of a GP are 24 and 3 respectively, then the sum of the first 6 terms is. Second term is given by AR. If I take AR square as a GP, AR, then the second term, which is equal to 24. Then the fifth term, that is given by A into R power 4, which is equal to 3. Okay. We are asked to find the sum of first 6 terms. Okay. I divide this equation divided by this equation. When I divide it, A gets cancelled, R by R power 4 will give you 1 by R cube is equal to 24 by 3, which is 8. So R cube is equal to 1 by 8, which implies R is equal to 1 by 2. That R is equal to 1 by 2, I will substitute here. A will be equal to 48. 24 into 2, 48. Okay, so we got A here and we have got R here. We want the sum of the first 6 terms. Sn is given by A into 1 minus R power n divided by 1 minus R. So here we want the S6, sum of the first 6 terms. A is 48 into 1 minus R, that is 1 by 2 whole power 6, n is 6 here, divided by 1 minus 1 by 2. So 48 into 2 power 6, that is 64. 1 minus 1 by 64 will give you 63 by 64 by 1 by 2 here. 63s are 64s are 2 1s are 2 2s are 63 into 3 is 189 by 2 is there. So answer is 189 by 2, second option. 15th question. The middle term in the expansion of 10 by x plus x by 10 whole power 10. See here n is 10, n is even. If n is even, then there will be only one middle term. If n is even, there will be only one middle term. That middle term is n by 2 plus 1 term. If n is even. this case, this formula we have to use. But I'll explain the other case also. That is, if n is odd, then what happens? If n is odd, then there will be two middle terms. If n is odd, those two middle terms are n plus 1 by 2th term and n plus 3 by 2th term. These two will give you the two middle terms. Okay. So now, since we have n as even in this case, so n by 2 plus 1 term is the middle term. N is 10 here, n by 2 that is 5. 5 plus 1, the 6th term is the middle term. To get 6th term, we have to put r is equal to 5. This is the formula we have, NCR x power n minus r into a power r in the expansion of x plus a whole power n. This is t r plus 1. So we want t5 plus 1, NCR 10c5 into 10 by x to the power n minus r, 10 minus 5, 5 into x square 10 the whole power 5. These two gets cancelled. So the answer is 10c5, option C. The value of this determinant. Okay. So we cannot take any common factors here. We just expand it. 1 into 1 plus x square minus z into minus z minus xy minus y into xz minus 1. Okay, that's equal to 1 plus x square plus z square plus xyz minus xyz plus y square. Xyz gets cancelled. So we have x square plus y square plus z square plus 1, which is the second option. Okay. Then next question, 17th one. The vertices of the feasible region of an LPP are. So 4 vertices they are given. The objective function is z is equal to 60x plus 40y is the objective function. Then the z max. So when this z attains its maximum at which point, or what is the maximum value? So you go on substituting these points in that. Z is equal to, we have 60x plus 40y. So 0, 0 if I substitute, I am getting 0, 0 only. Then if I put a 0, 15 by 2, that will give you z is equal to 0 plus 40 into 15 by 2. 20 into 15, 300. Then at 9 by 4, 45 by 8, if I substitute, 16 into 9 by 4 plus 40 into 45 by 8. That will give you 4 ones are 4 15s are 15 into 9 is 135. 8 ones are 8 5s are 5 into 45 225. The sum is 360. Yes, that is the maximum. You need not find out at 60. At 60. At 60 also you are going to get 360 itself. So it attains its maximum at 2 points. But that's not the question. The question is, what is the maximum value? Answer is 360. Okay. The 18th question. 1 by 1 into 2 plus 1 by 2 into 3 etc. up to 1 by n into n plus 1 is equal to. For such problems, you just put n is equal to 1 to 2 etc. Verification will get the answer. If I put n is equal to 1, I have to consider the first term. First term is 1 by 2. Right? 1 into 2 is 2. So now you substitute n equal to 1 in the options. First option gives you 1 by 2, so it may be the answer. Second option also gives you 1 by 2, that may also be the answer. Third option will become 2 by 1, which is 2, so this option is eliminated. Then here you will get 1 by 3, that is also eliminated. These two are eliminated. Now put n equal to 2. When I put n equal to 2, I have to consider the first and the second term, because you are finding the sum here. If you are finding the nth term, there by putting n equal to 2, you have to consider the second term. Here by putting it, we are finding the sum, so n equal to 2 means sum of the first two terms. Okay. So that is 1 by 2 plus 1 by 6, take LCM, 6 is the LCM, 3 plus 1, 4 by 6, 2 by 3. Put n equal to 2 in the options, only in these two options, because these two already we have eliminated. Put n equal to 2 here, 1 by 2 into 3, this will give you 1 by 6. So that is eliminated, only only that is left. That's the answer. Then if you substitute also 10 equal to 2, you will get 2 by 3. Okay. Then 19th question. If secant inverse of a plus b by a minus b is equal to 2 tan inverse x, then x is equal to secant inverse x, I will write cos inverse. Cos inverse of a minus b divided by a plus b is equal to 2 tan inverse x. Okay. Here I will divide by a. So 1 minus b by a divided by 1 plus b by a is equal to 2 tan inverse x. Then I can write this b by a as root of b by a whole square. Okay. This is nothing but cos inverse of 1 minus x square by 1 plus x square. This is equal to 2 tan inverse x. So you get 2 tan inverse root of b by a. On RHS we have 2 tan inverse x. So x is equal to root of b by a. Option C. Okay. Then go to question number 20. The perimeter of the triangle formed by the two foci and a point on the ellipse x square by 25 plus y square by 16 is equal to 1. So this is the ellipse. Two foci. There are two focus here. I will call this as S and this as this dash. And a point on the ellipse. Which point? You take any point on the ellipse. I will take a point here. I will call it as P. So this is the triangle we are talking about. S dash P. This triangle. What is the area of this? What is the perimeter of this triangle? They ask. Okay. So for any ellipse, you know SP plus S dash P. If S and S dash are the two foci and P is any point on the ellipse, SP plus S dash P is always equal to 2. Sum of the focal distances is always equal to the length of the major axis. Okay, so perimeter is the sum of all these. SP plus S dash P plus S into S dash. SP plus S dash P is equal to 2a, you know. S dash is the distance between two foci. Distance between foci is given by 2ae. Say S6 coordinates are ae, 0 and for S dash it is minus ae, 0. So difference between them is, distance between them is 2ae. I take 2a as a common factor into 1 plus a. What is a in this case? X square by a square plus y square by b square equal to 1. So a is equal to 5, b is equal to 4. So 2 into 5 into 1 plus e. Eccentricity, we know the formula root of 1 minus b square by a square. If a is greater than b, this is the formula we use. If a is less than b, we reverse it. Root of 1 minus a square by b square. Then, okay, 10 into 1 plus b square, that is 16 by 20. 1 plus 25 minus 16, 9 by 25, root of 9 by 25 is 3 by 5, so you get 10 into 8 by 5, 2 into 8, 16 is the answer. Option C. Okay. 21st question. If A bar and B bar are two unit vectors inclined at an angle theta to each other, then magnitude of A plus B will be less than 1 if theta lies to B. Okay. Magnitude of A plus B is less than 1. So if I square it also, it will be less than 1. Right? So its formula, you know, A square plus B square plus 2 into A r, that is less than 1. These are A bar and B bar are two unit vectors, so you get 1 plus 1. This is 2 into mod A mod B cos theta. Mod A mod B is 1, so 2 cos theta less than 1. So 2 cos theta is less than minus 1. 1 plus 1 is 2. Take into RHS. 1 minus 2, you get minus 1. So cos theta is less than minus 1 by 2. And obviously we know that cos theta, its range is minus 1 to 1. So here less than minus 1 by 2 is certainly it should be greater than or equal to minus 1 and less than minus 1 by 2. Okay, cos theta will be minus 1 at theta is equal to pi and minus 1 by 2 at theta is equal to 2 pi. So the answer is it lies between 2 pi by 3 and pi. See, in this interval, cos is a decreasing function. That is why at pi we have cos pi as minus 1 and cos 2 pi by 3 as minus 1 by 2. So the answer is option B, 2 pi by 3, 2 pi by 3 and pi. Okay. Then, if magnitude of A is equal to 8, the magnitude of B is equal to 3, magnitude of A cross B is equal to 12, then the value of A dot B is. Okay. So you know this formula, magnitude of A cross B whole square plus magnitude of A dot B whole square is equal to magnitude of A whole square into magnitude of B whole square. You know this formula. A cross B, magnitude of A cross B is nothing but magnitude of A, magnitude of B into sin theta. So here you get magnitude of A square into magnitude of B square into sin square. This will give you magnitude of A square into magnitude of B square into cos square. So if I take mod A square, mod B square as common, then we will have sin square theta plus cos square theta, which is common. This is the formula. Let us substitute. Mod of A cross B, that is 12 square is 144. Plus this is what we know. That is what we have to find. Mod A is 8 diagonal, so 8 square is 64 into B is 3 square is 9. 64 into 9, 540 plus 36, 576. 144 plus mod of A dot B whole square is equal to 576. A dot B whole square is equal to 576 minus 144, that will give you 432. So magnitude of A dot, A dot B is equal to square root of 432. 432 I can write as 16 into 27, right? So it will become 4 root 27. Do we have to substitute 4 root 27? No. Right, 27 as 9 into 3. So that will give you 12 root. Okay, option C. Then let's go to the next question. If magnitude of A is equal to 3 and K is between minus 1 and 2, then magnitude of K into A bar lies which into. You know this formula, magnitude of K into A bar is equal to modulus of K into modulus magnitude of A bar. That's equal to magnitude of modulus of K into modulus of A bar is equal to 3. Okay? So K lies between minus 1 and 2. When K lies between minus 1 and 2, K is greater than or equal to minus 1, less than or equal to 2. This will imply that modulus of K is always greater than or equal to 0, less than or equal to 2. So modulus of K lies between 0 and 2. So modulus of K into 3 will multiply this by 3 will lie between 0 and 6. 0 and 6.